Hello, my name is Giacomo Collini. I would like to welcome to my quick session about crypto compliance. Today we're going to talk about how Clovr Labs is tackling compliance for the crypto world and how we are using graphs to make sure we are successful in our endeavor. Clovr Labs is a small group of people based out of Barcelona, but we are actually distributed across Spain and more in general Europe. We are fully distributed, async, and we in general, our main business is building prototypes for a handful of clients, and our area of specializations are security and crypto, although we have experience in enterprise software engineering and other areas as well. A quick gentle introduction to Bitcoin. I guess at this point most of you will know what Bitcoin is. Bitcoin is basically a virtual currency designed as a money and also as a form of payment. The project started roughly in the 2010s and gained tractions in the last few years with has been a bit of a roller coaster, but there is certainly some merit behind the technology and the movement behind this tech. And basically, the main value of Bitcoin is that it is decentralized. So compared to a common currency like the dollar or the euro, Bitcoin has not a central bank supporting it, and the value is purely driven by the market. It's based on cryptography. Basically, that means that all the transactions are signed by a cryptography algorithm to make sure they are legitimate. And definitely, as you can see from the chart, adoption has been increasing for the last few years. And actually, the 50% of the crypto holders have purchased Bitcoin in the last year. With this, there is also a push for compliance, as there is a trend for Bitcoin to be accepted more and more by institutional entities or banks. And that, of course, also pushes the need for more compliance controls. And that's also an interesting factor. Basically, as I mentioned, Bitcoin is a public ledger, and that means that all transactions are public. The transactions parties are anonymous, so you don't know, looking at the ledger, who is transacting with, unless you are able to identify a certain Bitcoin address with an entity, a person or a company. At that point, you will be able to track all the activities of that company in the blockchain, at least for that particular wallet. A company or an individual can have more than one wallet, but in general, I mean, as you move the money through, all these transactions will be visible in the blockchain. The Bitcoin blockchain, compared to other blockchains, it's a bit less feature rich. So for instance, you may have heard of NFTs or non-fungible tokens or other kind of smart contracts. Those are usually based on blockchains like Ethereum or Polygon. Still, Bitcoin got some features around multi-sig, so multi-party transactions, and other kind of features. The main problems that Bitcoin is suffering now are transaction fees and execution time. So Bitcoin is not scaling as fast as the adoption, and that is posing some scalability issues for the present and the future. Although there are different working groups working on solutions for this. Crypto compliance. So when we talk about Bitcoins, we are talking about an asset or a class of assets that have value, and then they can be seen as gold or money or other kind of assets. And countries are taking different approaches to compliance. You go from banning Bitcoin completely to legalizing it or using it as a legal tender. That it's happening in a couple of countries. And then you have a middle ground approaches that in general are, I mean, the main focus has been on taxation. So the legal framework around how you should be taxed for your Bitcoins is kind of well understood. Of course, nobody really likes it, but the rules are quite clear. On the other hand, when we talk about risk and fraud, there is still a certain distance between what legislators are doing in different countries. So the area is developing fast, but it's certainly true that as there is a push for Bitcoin to become more legitimate, that will require also the establishing compliance processes that are sanctioned by authorities. One example of this is the travel rule, which is it's a new regulation that is gonna be in place in the near future, that will require extensive know your customer and anti-money laundering practices by the operators in the Bitcoin space. And this will basically put at parity the compliance requirement for crypto with what we experience every day with what we call fiat transactions. So let's say USD or Euro transactions. And this is a summary of the challenges already mentioned. So there is no common legal and regulatory framework. And of course, Bitcoin being a a global network, a bit like the internet, is suffering from the same inconsistencies, as you can see on the internet, where some content may be legal in a country, but not in another, etc., etc. As of today, there are a few companies that have been emerged out of the group, and these companies are providing solutions that looks pretty complete, taken singularly, but if you compare the results, you will get inconsistent results, and that's because the concept of risk and the regulation is not consistent. Also, these companies are from different countries, so their interpretation of compliance may be different. Another factor is that the Bitcoin and the crypto movement started as a bit of an anarchist movement and quite distant from the compliance and regulatory world. And so that distance is certainly impacting the communication and collaboration across the various parties, and which is not contributing to the speed at which compliance is implemented. And that's where ChainPrint comes into play. So ChainPrint is the name of the project by Clovr Labs that aim at exploring compliance in the crypto space and develop tooling for the various parties. And what we are trying to achieve is actually the computing risk scores for blockchain transactions and addresses, so to be able to highlight nefarious actors and contribute to the well-being of the ecosystem. We decided we tried a different kind of technologies for our for our challenge. So this project started as a pure exploratory task, and we've been testing with various technologies, and many of them were promising until we started to when we started to compute the whole blockchain. So the whole blockchain, depending on your media, it's it's 1 terabyte to 5 terabyte big, depending on the amount of features and properties you include. And when we started processing the whole blockchain, many technologies failed. And at that point, first we realized that graphs were the best model for us, given that the blockchain can be easily seen as a graph. The graph model is basically native to the blockchain. And then when looking at graphs technologies, we actually benchmarked a few of them, and at the end we settled with TigerGraph, which was the only one that allowed us for timely ingestion of the whole blockchain and processing. In particular, the ingestion was where actually we were really happy about the performance we reached with TigerGraph. We are also, at the moment, we are really focused on blockchain, on the Bitcoin blockchain, although we are looking at other blockchain as well. In particular, Ethereum is a blockchain where we want to do work. So basically, what you can see here is a subgraph that represents a set of transactions for which that connects address 1 on the left with address 6 on the right. So basically, here you can see a subset, a window on the blockchain where actually this information is all public. So looking at the blockchain, you can look at the source of fund of address 1 and follow it through over time. So the basic principle of analytics, compliant analytics for the crypto world is follow the money, and until you find a source of fund which is a known actor. So a known actor could be a good actor, could be a legitimate exchange like Coinbase or Kraken, or could be a dark web marketplace. And basically what we do is the basic use case is to label the source of funds, the funds in address 1, depending on where they come from. So if you look, for instance, here, the distance between address 1 and address 2, I mean, here we are seeing clearly that address 1 received money from an address that was associated with a dark web, with nefarious activity marketplace. So there is clearly a risk concern here in relation to address 1. In this example, address 6 is seen as a neutral address, so we don't know much about it. But if you're assuming it was a bad address, you could argue that it's so far in the chain that we cannot deduct any risk metrics from the fact that we received money from it. If this was fiat money, I mean, $1 is same than another dollar. So the only way you could track this depth of a relation so deep is by following bank transfers and etc. But in the blockchain, each Bitcoin is different from another Bitcoin. A Bitcoin is made of satoshis, and so you can see them as cents, although I mean there are several satoshis for a Bitcoin, but each satoshi is tracked on the blockchain. And And so the fact that if we assume that address 6 is a bad address, we also need to consider that there are specific techniques that, let's say, artificially increase the distance between two addresses, actually to hide the origin of funds. So, I mean, it doesn't matter how far is my source of fund. I mean, there can be a risk relevancy on that relation. And that's a bit, and here you can see, first of all, how the transactions graph is a graph. And second, you get the basic understanding of our use case. We want to follow the money that get to a specific address, and then we want to use data about these other addresses to compute our risk. So I'm gonna go a bit more in detail about the first problem. So here we actually identify two problems. The first problem is traversing the blockchain graph in an efficient way. The second problem is finding the bad guys. So let's say finding, let's say being able to label addresses as because we know they belong to a bad actor. So for the first problem, basically, you can see how we mapped the blockchain to a graph, in this particular a graph in Tiger Graph. And this graph is basically a generic graph that is modeled after the blockchain. And at this point, we are able to apply different problems to these generic graphs. For performance reasons, we could improve these graphs to make it more efficient, but then it would be more efficient only for a specific class of problems, while we are trying to keep a generic graph and then apply different hypotheses to it. And I mean, and that seems a good thing for us at the moment. I mentioned already before how ingestion was a difficult step for us when we moved from a POC, from a proof of concept stage to the full productionized setup. I mean, we had to identify the right technology, and we did it. And performance is still difficult to model because as a given address can have received money by we don't know how many, we cannot forecast how many addresses have a relationship with our target address. So the graph can scale horizontally or vertically in an unpredictable way. And that, of course, makes things difficult when you plan to build, let's say, for instance, a reliable transactional API that produce a risk score for a given address. But yeah, I mean, at the moment we are having enough success with this. So the first problem is basically traversing the graph, and the second problem is actually finding the bad guys, which usually is a two-steps process. Usually there is a first phase where that we call a secret shopper phase, where basically somebody using OS intelligence techniques collects addresses from known entities. So consider that you could go to the dark web, and if you try to shop something, you can find a number of addresses, and then you know that those addresses belong to certain entities. This is, of course, a simplistic example. And then the second, so this is the first step. The second step is applying models and machine learning to predict what other addresses are belonging to the same entity. And this is where we use GNN and still Tiger Graph to compute, to predict this cluster of addresses. And of course, this is a complex problem that also need to be approached in a scientific manner, and it's probably the most interesting problem we have. And for this, I have to say that Tiger Graph is supporting us also with their own research, and they are helping us advance on this topic as well. The conclusion are that crypto blockchains are evolving fast in any directions, and compliance is certainly one of the main factors that will influence how crypto adoption will change in the future. We see compliance. Our team comes from a security background, and so we had to deal with evolving compliance, as also compliance is evolving for information security, for instance. But for the crypto world, we see it as a decisive factor for how it's going to evolve. Graph technology is, for us, has been the winning technology to tame the blockchain for both our classes of problems. So traversing the blockchain and extracting basic or consolidated data, but also applying graph neural networks to predict fraudulent or addresses, or in any case, to be able to associate addresses whose identity is unknown to specific entities. And in this slide, you can see an example of our API that is leveraging Tiger Graph as a backend system to provide information about Bitcoin addresses. And this ends my presentation. Thank you very much.